it was good, but like everything was new to me.
Mhm.
So it went quite like I had some trouble regarding some topics. So I had to view the videos again and again to clear those topics.
Okay.
But
Okay.
then it was clear. But still, my quiz 4 is remaining. Uh,
Okay.
I will complete it by today.
All right. All right. Yeah. Just waiting for Raghu to show up and yeah. How did you find it, Aishwarya? How was the module? How were the quizzes?
Yeah, actually, I found it quite, I mean, not easy and not difficult. Like it was medium for me.
Mm-hmm.
So yeah, like after watching the videos, like I was able to solve some of the questions in the quiz.
Awesome. Yeah. And also, did you guys, look into the notebooks that were there for the demo videos?
Yeah, yeah.
Intention behind having those notebooks were, to give you guys an exposure, kind of, the hands-on along with watching a video so that, you can parallelly work on and then get to that um, pointers then and there itself. So how did you find it? How with the demo videos and even notebook? How was that experience basically working along with the video?
Yeah, actually, it was quite good. Like because but in order to implement the code, we need to have the basic foundation. So whilst watching the video, like parallelly, we are implementing the same code in our systems.
Mhm.
So while doing that, we find it quite easy, like so that we can able to add some more code, like some more content, like using different
Experiment it out.
yeah, different topics, and I mean using different plots instead of block box plot, we are using histogram, like something like that.
Absolutely. Yeah. Awesome. How about you, Kunal?
Today I will do that thing, that Jupyter notebook. So by today,
Okay.
I complete that quiz also. That is quiz 4.
All right. All right.
Till now, the theoretical part, that is the everything, the formulas and every thing which was explained in the video, it is clear.
Awesome. Sure. I think we have Aditya as well. Hi, Aditya. Hello. All right. So coming to the course, I mean the content that we had in the module work were, to cover up the basics, right? To even, before starting with actual model building in the machine learning project pipeline, we do perform some of the tasks like, preliminary and essential tasks like exploratory data analysis and doing, pre-processing our data and performing some feature engineering sort of things. So all those were, essential bits in order to get started with building predictive models, even before starting with building predictive models and such that, right? Cool. So was that clear? Like, were you guys able to gain that confidence in order to explore the data and pre-process it before even considering building a predictive modeling, things like that? How important you guys did find those topics were?
Yeah, actually I found them as very important because in order to build a model, we need to have the exact features. Like before, I mean, what I understood from the videos is that we have to do some pre-processing techniques like feature selection, feature extraction in order to build the best model. So yeah, I
Right.
feel that they are very important.
Yes. Yes, that was also one of the, intent to have this module in the entire coursework, to give that strong foundation in order to gain that data mindset, as well as, have some exposure for all these data exploration and data pre-processing techniques before jumping on to actual, core of data science project, that is building predicting models, right? Awesome. Yeah. All right. Kunal, would you like to comment anything on that bit? Like how important was the module for you? How did you find?
The
Oh.
topics were quite important for me as it was new to me. So the every new topic, like every new topic was something new to me, and as well as important, because every topic has its own use in the for the future model building. Uh,
Correct.
so
Yeah, absolutely. Sure. Aditya, you there? Okay. All right. All right, guys. Raghu, would you like to add anything to this discussion before starting with their doubts?
I'm sorry, Archana, can you come again?
Yeah, I was just asking, I know I was just checking on, like, would you, do you have anything to add to this discussion, or we can start with their doubts?
No, I think, this module 3 in the course covers a lot of important concepts, right, from that you mentioned. And like, I really don't have anything to add, but it's very important to understand all these concepts thoroughly before we move a thing further. And I hope you attempt the quizzes and the hands-on session as well.
Correct. Sure. Then let's start with your doubts. Kunal, let's go with yours then.
just a second on this one.
Yeah.
Just one thing, that was bias and variance thing.
Mm-hmm.
In that, that was not clear to me, uh, like what actually it does.
Yeah. So,
So
whatever you have understood, would you like to just comprehend? Like from that, we'll understand that where you're going wrong and what exactly you
like
understand.
from the module, from the video, it was there, like bias is used for like if the problem is simple, and if there are low errors, like a limited amount of errors are there,
Mm-hmm.
as in when the errors are increased, then the concept of that then the variance come, because the problem is complex. So
Can you come again?
I'm like, in bias, the simplicity thing.
Mm-hmm.
Like in bias, if the amount of errors are less,
Mm-hmm.
then like in the video, the total amount of if the total amount of errors are less, then we can use bias, and we can just predict like the total, if the module will throw any error or not. And in variance, if the errors are more, so we will use variance to see, like from the graph. I couldn't understand the graph basically.
Correct. So basically, Kunal, this bias and variance are type of errors that we come across while evaluating a machine learning predictive models, right? So what they're trying to say here is, whenever we say that our model has shown that it has high bias and low variance, then we call it that model is actually underfitting our data points, as in it is basically basically that is inferring less of learning less from our data point, hence it is causing underfitting. So basically there are two types of the challenge or the kind of error that we face. One is underfitting and overfitting. How we
Okay.
can differentiate these two are like, when we say our model is underfitting, basically there'll be two things. One is that our model, that machine learning model, that whatever we have built, it is not learning well. It is not basically inferring the information, or it is not learning our data well. Basically, to just put it in simple words, it is not learning well, it is not learning our data well. So the model is underfitting because of high bias and low variance. And in the other hand, when it comes to overfitting, we say it as like, it has low bias but high variance, as in data is, the data points are uh, populated with much variance, from one data point to the another. The distance between them, they are varied very much. Because of that, our model is trying to learn very much. So it is coming up with very complex curve lines and trend lines in order to learn the data. That will be causing overfitting. So we have this trade-off. Whenever, in order to get rid of underfitting, we try to, either increase the variance, or increase the variance or lower our bias in order to overcome underfitting. So in that case, when we try to play between these two, uh, again we'll kind of stumble upon these two errors. Sometimes it might cause underfitting or overfitting. So while playing with these two elements, that is bias and variance, always there is a trade-off. Whenever we try to lower the variance and increase the bias, and the model causes overfitting. And when we try to lower the bias and increase the variance, it causes overfitting. So yeah, that is what we call it as trade-off between bias and variance whenever we try to build a model, or trying to optimize our machine learning model, predictive model,
Okay.
right? So yeah, these two topics, actually this is a little bit confusing when we speak about it, but speak about it at this level when you are at exploratory data analysis phase. So once you pass on this model building and coming to evaluation phase of that machine learning life cycle, you'll understand better than how to deal with, how to even notice that whether your model is underfitting or overfitting, considering your actual predictions, actual values, and your predicted values. You do bit of comparisons. We have some matrices for the same. So matrices like evaluation matrices like accuracy, precision, recall, and there are many for certain for specific machine learning models. When it comes to classification modeling, we have an accuracy. So from that you can basically look into it, how your model is performing on training set and your testing set. Let's say your model has performed very well on your training set, but not well on your test set. Then we can call this as an underfit model, because it is performing well on your training set, but not in your test set. That means your model has not learned your data well. In the other way, in the other hand, overfitting is the other way around. Your model is performing supremely well on your test set, but not on your training set. So it means that your model has learned very well, like each and every data point in your data set, even with having high variance, how the data point are spread it across. Your model has tried to learn each and every data point. So because of that, it has come up with a very complex curve, complex model basically, in order to learn each and every element, each and every data point from your data set. So it has caused the overfitting, hence it is performing better on your test set rather than your training set. So yeah. So this is always a trade-off. Whenever you try to tune your bias and variance, one or the other thing will happen because of high bias, high variance, low bias, low variance sort of thing.
Okay.
Right. Yeah. So to just put it like, again, like to conclude it, whenever you have high bias and low variance, it causes underfitting. And whenever you have low bias and high variance, it causes overfitting.
Okay.
Right. So one or the other error will be there. So that's why we call it, there is a trade-off between these two. Right. Make sense?
Yes, ma'am.
Correct. Anything else? Raghu has just done something. Give me a sec. All right. Yeah, Kunal. So hope that was clear, right? Why do we call that bias and variance as a trade-off in this life cycle, machine learning life cycle? Cool. Anything else beside that?
Nothing, ma'am.
All right. And this is also very, important topic, even when it comes to interview point of view, from interview point of view, this is, kind of uh, essential topic to be aware of, because it's quite confusing as well as very important when it comes to tweaking the model and evaluating the model after building the predictive model. So yeah, you can even again revisit the same in order to understand it in a better manner and yeah, explore it. I would suggest you to maybe, it's also a very best practice while learning to write up a blog, like, whatever you have understood, you can just for your own learning, just start it out with this practice, write up a blog for your own understanding and then try to comprehend it in a better manner, like, bring in good grammar and little bit, try to simplify the write-up and share it with your friends. Ask them if they can understand your explanation, things like that. Even you can share with us, during this course, but it's also a good thing. And also, that you have this Discord community of ours. So you can also post it out there and ask, fellow mates, community members to review it, ask their suggestion. That way, you can also make your understanding better. Correct. Yeah. Aishwarya, go with yours.
Yeah. Like while you are explaining bias and variance concept, like do we have a case of like low bias and low variance and high bias, high variance? Hello?
Right. So I was saying that low bias, low variance is actually the worst kind of model that you can have. It's not performing well on the training set, and it's neither performing well in the testing set. Right. So I mean, it's your model is not at all capturing any trends. Talking about uh, high bias and high variance. So that again, like thinking about a case. So like, what do you think? What should happen when it's high bias and high variance? Like anything that you can think of that this might happen.
Okay, like maybe the model performs very less accurate, is something like that.
See, it's about the training and the testing sets that we are talking about.
Okay.
So if there is a small variance, that means whatever the model is predicting on different data, they are pretty close to each other. And
Okay.
high bias means that whatever is actually the answer, the model is predicting something else, right?
Okay.
So you must have seen that target, that bullseye thing. It was
Yeah.
there
Yeah.
in the video as well. So the bullseye is what actually needs to be there. High
Okay.
variance means if we use different data sets and apply the ML algorithm on it, um, the answers will be close. Now, will they be actually what is, will they be actually closer to the actual values, or will they be closer to some other value? That depends upon biasness.
Okay.
If there is high bias, then those values will be like not near that bullseye, right? They'll be far away. And so high bias and high variance means that it's not closer to the bullseye. That means it's not actually predicting what it should predict, and all of these values are somewhat in a different zone but closer to each other.
Okay. Okay. Got it.
Like scattered in the video it was shown.
Right.
Correct. And again, to just conclude it in a very still simpler way, like Aishwarya, you asked, what if it model has low bias and low variance? Then we can say actually the model has that balance, because as I said even earlier, right? Whenever a model is what built on it is showing high variance, then a model is overfitting, and whenever it is having high bias, then model is underfitting. So high variance, then it is overfitting. High bias, then it is underfitting. So there is a trade-off. But when it comes to low bias and low variance, then there we can say that a model is having actually a good balance. It is kind of neither a simpler model or nor complex model, but it is of balanced
Okay.
model. It is performing better. So we can call that sort of models as a balanced model or good model. But
Okay.
in case of the other thing that as Raghu explained very well, that another case, like both the cases, like having high bias and high variance, both the things are high, then it is worst model. Not at all considerable. It is like extremely out of sight, because and also there won't be such model, like logically speaking, there can be one is overfitting and underfitting. If not both of these cases, then thinking of having model having both high variance and high bias is something not that logical, is also what I feel. It's also kind of debatable topic,
Okay.
it in that way, right? But low bias and low variance, good model. High variance, it is overfitting. High bias, it is underfitting. But the model which is having both high variance and high bias is like, again, it's not good model, but one thing, and also logically, it is still debatable sort of topic, open for a lot of theories and understanding,
Yeah. Okay.
right? How does this sound, Prabhu? Would you like to comment again?
Yes, I think you've concluded it very well. Also, I think like if the data sets itself are very different from each other, then we might come across this high variance
Correct.
case.
Correct. There could be such cases as well.
Right.
Everything depends on quality of data. That's why this module, where especially EDA bit, where we perform feature engineering and pre-processing, is crucial because of this. In order to overcome all these sort of challenges and uncertainties in our data set, to get rid of all such uncertainties, and that would be impacting negatively on our predictions after building, post to our model building, right?
Okay.
Yeah. That was a good question, by the way. Yeah.
Yeah, and also in the code, I have a few questions. I mean, few doubts.
Okay. Would you like to share your
Yeah,
screen?
yeah. Can you allow me to share my screen?
Yes. How about now?
Yeah.
Good.
Yeah, is my screen visible?
Yes, yes.
Yes. Yes.
Yeah. So in the code, like what I was like my doubt is here, like what is this sort of graphs? Like is it a scatter plot or like I didn't get this
Okay. Definitely.
pair plot?
But the thing is, here we have bought, we have combined all the features together instead of plotting it individually, right? Like
Okay.
scatter plotters for, having that comparison between two independent variables, to check upon how they're distributed and how the data is populated, right?
Okay.
It's a scatter plot, but it's a combined plot for all the features that we have in the data set, right?
Okay. Okay. Like what should I do in order to get the single scatter plot? Like the
Yeah,
code.
it's again like you can just do it like with the scatter plot function. You can just call and mention particular the features that you want to look into, and then you should be able to get
Oh,
or desired scatter plot for concerned features.
yeah, yeah, fine. Like, can I know here, like, I didn't get where the feature extraction is performed. Like, here we are taking the categorical variables and all. Like,
Correct.
yeah, where exactly the feature extraction is done.
Feature extraction as in
Yeah, extracting, I mean, the important features.
I think
important
this
feature that
particular notebook only consists of visualizations.
Okay,
correct.
Uh, So this is like exploratory data analysis, the first step
okay,
that was
okay.
included in the model.
Yeah, okay.
Correct.
In
So
the
when you
model.
say that feature extraction, we can also put it in that way that it can also be called as checking the feature importance through a correlation maps, right? Where we plot a correlation between two features, independent features, and all the features, so
Oh,
that we get to know that if two features are highly correlated, positively correlated, then there is no use of having both the features, because our model will be learning same sort of pattern from both the features, and it also comes with computation cost. So in order to get rid of all these challenges, we can take off either of those features from highly correlated features, so that we can have one among those two, where a model can still perform the same way or still better, instead of having all the features and making our model pressurized to learn about lot many features, which
okay.
giving us same information about the case.
Yeah.
Like checking these correlation matrices will help us determine multicollinearity. So if we are using some linear regression model, then maybe we might need some feature engineering before we are applying the model. So things like that.
Okay. Yeah, and one more thing is that what exactly the difference between the, I mean, this bar and bar graph and this box plot.
Box plot.
Yeah, box plot.
Yeah. So this one is basically used. You see this tails, right? Where we use it to measure the outlier. So let's say, and also the skewness of our data. While pre-processing our data, we'll also check on this assumption that whether our data is normally distributed or not, things like
Okay.
that. So if we see any data points that are um, extremely towards left or right, and if the tail is not able to reach those data points, then we say that our data set is skewed either towards left or right. That means there are some outliers, then we need to remove it.
Yeah, basically, I mean, the points are the outliers,
Correct.
right?
Correct.
Okay.
Yeah, correct. That's why you use this. Otherwise, coming to bar plots, it is just, which gives histograms, or bar plots just gives, the distribution of our data set, whether, distribution of features, whether they are normally distributed or not,
Okay.
right? And also you can use bar plots for, having accounts of your various classes or categories in your data set. Like, let's say in this data set, you might have various classes for some feature, right? For categorical, any of your categorical feature, you might have classes or categories. So if you want to have a count of these categories or classes, you can have your bar plots to have the count, so that even it visually represents in a simpler manner, and also easy to analyze it.
Yeah, okay, I understand. Understood.
Correct.
Yeah.
Sure. Anything?
Yeah, no, like those two doubts I was having in that.
All right. So were you able to even wrap up your quiz bit, all the quizzes?
Yeah, actually, I was trying to do the quiz. Like most of the questions, like I found it. Some of them are difficult, like, and some of them are easy. Like, yeah, I'm trying to watch the videos and then try to solve the questions.
Awesome. And also, you guys have an access to this doubt tracker, right? Kunal, it's for you as well. And maybe, you can just drop in there, and, we can have a discussion. And for your last week's question, Kunal, like regarding
Yes, ma'am, I got that in the doubt.
the tracker.
Yes, ma'am.
So there was an error on elements, right? The typo error was there. That's why I think you would have copied the same bit, same thing, like both inward quote or something. That's why it might be it was throwing an error. Ideally, it should not be throwing an error if you pass in a string with a double quote.
Okay.
Yeah. So option B was the wrong option, like
Yes,
because it has a special character that is additional thing.
yes, ma'am. If there was an option to select both of the options, so I would have select both the options.
Both, okay. But still, option C doesn't throw an error because it's still a string. It is, it was able to typecast it to a float, right? It should not be throwing an error. Option C was not throwing an error, like if you put it in a right quote, correct quote. It only throws an error if the string has any special character in it, space or hyphen or any special character in it.
Okay.
All right. All right. Guys, anything?
No.
Nothing much. All right. Beside that, how your other activities going on beside the coursework? Just casually checking on you at your work. It could be Kunal and your Ashwaya. All fine. Like, are you guys able to manage time with your other commitments and also the coursework?
Yes, ma'am. I'm easily able to manage all the things.
Okay.
Even I am able to manage.
Awesome. Sure. That was good thing. and you both are there on Discord, like, get active, like even, suggested last week, Kunal, Aishwarya, but it's not there. Yeah, guys, stay active there because it's a good opportunity, to put it, very, uh, honestly putting it out. It is very, it's very much beneficial in terms of having a network of data professionals and to recheck or have that self-assessment sort of thing within yourself, how confident you guys are on specific topic, having multiple reviews or uh, opinions of various the data practitioner, data science practitioners opinions, right? Various opinions from many professionals will help you guys have that self-assessment sort of thing to you know able to understand where you stand in the journey and where there is a scope to improvise, where you are good at, things like that. All right. Raghu, over to you. Would you like to add anything?
Right, about the community itself. We regularly try to put in some quizzes and even job opportunities. And sometimes someone else's doubt will be your doubt in the future. So it's always a good option to keep interacting and try to research about something that is being asked in the community, and just hang out there, stay active. There's also a humor section, so it's not all studies or all work. You can also have fun learning data science.
Yes, ma'am. Yes, sir. Sure.
Yeah.
Perfectly said. Yeah. All right. Are we good to end the session? Then coming to the next session, Kunal and Aishwarya, it will be uh, next Monday, right? Would that be fine? Will you guys be able to wrap up with your quizzes and everything? Basically, the next module, the next session will be on auto ML. Like already discussed, we'll have a recording of auto ML, that is your Radicl platform, in order to perform auto ML. And yeah, we'll walk through a GCP setup and how to get your Radicl, and running for your experimentation and stuff. So that will happen on Monday, right? Sure. All right. And this week, you guys can utilize it for your self-revision sort of activity. You can explore various other resources, external resources, like, and if you find anything difficult, anything weird, which was not taught in the coursework, can put it on Doubt Tracker. And also on Discord, we'll, try to address them and get them resolved, right?
Okay, ma'am. Sure.
Yeah.
Awesome. I think that was all about that. Sure. Maybe we can end the session, right?
Yes, yes.
Yeah. Awesome. Thanks, guys. Thanks for joining in. Happy learning.
Okay. Thank you.
Thank you.
sir.
Have a great week ahead.
You too, ma'am.
Thank you.
So in the starting of the 20 minutes of this session, Shala called me, and regarding Sanvi.
Okay.
So she actually had texted earlier in the day to Shala